Okay, so let's go ahead and take a look at what kind of problems we're going to see when it comes to solving log equations. So here we have a log equation. Okay, this is different from an exponential equation because exponential equation, the variable is in the exponent. Log equation, the variable is in the log. And so if we look at this problem, I'm going to go ahead and just write it onto a different page here. We have the natural log of 4x minus 7, and this is equal to the natural log of x plus 5. Okay, so this is considered a log equation because our variable x is in the log. Now, this one is solved in a very similar way to the way that we first solved like our very first exponential equations. To solve this one, we need a property. So the property we're going to use, it's just a normal property of equality. This is the property of equality for logs. So the property of equality for logs states that if you have an equation, and on the left side of the equation you have a log with a base number, and you have something in that log, okay, we'll just call it x for now. So you have something in that log, we'll say it's x. And on the other side of the equation, you have the same log. So we'll say a log with the exact same base. But we have something different inside that log. Okay, so let's say that we have something different. Let's say that we have y inside this other log. Now, what would this property tell us about the relationship between x and y? If these two sides have to be equal, what does that tell us about x and y here? Well, if we're taking a log, the same log of two different things, the only way that these things are going to be equal if these two different things are actually the same thing. So the only way that these are equal is if x and y are the exact same number. So if x and y are equal to each other, then this can make sense. Okay, so this is essentially what this property says, is that if you take the same log on both sides of two different things, then those two different things are actually equal to each other. An example of this would be, like a simple example of this would be an equation like log base 9 of x is equal to log base 9 of 12. According to this property of equality that we have here, what would that tell us about the relationship between x and 12 here? Yeah, they're the same. They're equal. In order for both sides to be the same, x and 12 would have to be the same thing. X would have to be equal to 12. And this is the property that we're going to use to solve these types of equations. So let's use this to look at our example here. So if you take a look at our example here, we have a log on one side, and inside that log is 4x minus 7. I meant to do it. And that log has a base of e. It's a natural log, so it has a base of e. If we look at the other side also is a log. It's a log of x plus 5. Not only that, it's the exact same log. They're both natural logs, ln and ln. So what exactly does this tell us about 4x minus 7 and x plus 5? They're equal. Right, they're equal to each other. So we can set up an equation where these are equal to each other. We can say, okay, well, what I know is that 4x minus 7 has to be equal to x plus 5. In order for this equation to make any sense, 4x minus 7 and x plus 5 need to be the same thing. Well, now that I have this equation here, and I'm only trying to figure out what x is, this equation is pretty easily solved for x. So I'm going to go ahead and solve this for x, and once I solve this for x, I'll have the solution to the original problem. Okay, so the way I like to solve these types of problems, I don't know how everyone does them, but I like to just move everything to the left side, set it equal to 0. So I'm going to subtract x to move that over, and I'm going to subtract 5 to move that over, and that means there'd be nothing on the right side, so it would just be equal to 0. So I would have 4x minus 1x, that's 3x. I would have negative 7 minus 5, that's negative 12. And then all I would have to do is figure out what 3x minus 12 equals 0 is. Plus 12, yep, plus 12. Divide by 3. Yep, it's 4. So you got 3x is equal to 12. Divide by 3. You got x is equal to 4. Okay, so really, did we even have to do anything with these logs here? No, we did nothing with them. Okay, so I mean, it barely even solves like a log equation because we didn't even have to do anything with these logs. Now, one thing to keep in mind though, which we'll see tomorrow, this only works if both sides have the same logs. Okay, if it looks just like this is the only time this will work. Okay, tomorrow we're going to see some problems that only have one side with a log, and we'll see how to solve those. They're also not too hard, but they're not as easy as this, that's for sure.